Good morning, students. Once again, here we are with the third physics chapter. Okay, since we have finished the first two chapters, we will begin with the third chapter, which is machines. Okay, now let us have a general view of what we understand as of now in terms of the word machine. Okay, now machine, as I understand, most of you must be interpreting a machine as something that makes our work easy. Okay, some device or some instrument that helps us in doing the things easily, doing some work easily. But it is not just that. As and when we understand, when we begin this chapter, we'll come to know that the work of a machine is not just to make our work easy, but it can also, a machine can also speed up our work. Okay, suppose for instance we have to do some work quickly. Okay, although without the use of a machine also we can do that particular work, but then the speed at which we will be working without that machine or that device would be far lesser. Okay, so when we use a machine, it can also be number one, for ease of doing work. Okay, then it can also be for increasing the speed of the work that we are doing. If we want something to be done quickly, okay, then we will have separate types of machines or different kind of machine. Okay, so similarly we can also have a look at the third aspect of it. You see, favorable point or direction of application of effort. Now before we understand this point, there are a couple of things that I would like to explain to you, since these are a little technical in terms of the usage. So we will first understand what is the meaning of the word load and what is the meaning of the word effort, which will be used quite often in this chapter and henceforth. Okay, so load, let us understand load. It is a resistive force, or in other words, it refers to the things or the mass or the weight that has to be lifted or moved. Okay, let's say a very basic example. Suppose we have a big piece of stone lying on the ground. Okay, now that is the piece of load. Suppose it has to be lifted up. Okay, so what has to be lifted up becomes the load. Okay, and the effort, when we talk of the effort will be provided from our side. Effort will be provided from the side, from the end of the person who wants to carry or lift that particular load or move it to some other place. Okay, so we can also say that effort is our input. The person who wants to do the work, he will be at the input end. So the effort, the force that he applies at his end to begin the work, okay, that is the effort. And whatever load or material or things or resistive force he is trying to overcome, that will be load. Okay, so it is very obvious to understand. Note over here is that effort will always be provided on the input side and load will be the output side. Okay, so there is some input to be provided to get some output or to get some result. Okay, so now having understood load and effort in terms of their definitions and all, so you see, load can be represented with a capital L and effort is represented with a capital E. Okay, now coming back to the third point that we were discussing, in machines, favorable point or direction of application of effort. Okay, there can be instances wherein simply by changing the direction of the application of effort, you can make your work easy. Okay, so when will be those situations? What will be those particular situations? What circumstances will they appear in? Will they come in? So we will study all that in detail. So as of now, please understand that the generic definition of machines should cover all the aspects of the different kinds of a machine. A machine can make our work easy in terms of the application of effort. It can also increase the speed of doing work, and a machine can also provide us with a more convenient direction or point where we should apply our effort, where we should do the work so that we get a favorable outcome. Okay, so the general definition you will find in the book. Please go ahead and read it. Now let us understand what we have discussed till now with a few examples that I have taken. I have drawn a few diagrams as well, which will help you in understanding better what we have been doing till now. Now let's see, let's look at the first situation over here and try to match this particular example or situation with the first point that we had covered under machines. Ease of doing work. Okay, now let's see, suppose this is a piece of a load. Okay, now the weight of this particular piece of load or stone is 100 newtons. Okay, so load becomes 100 newtons. Okay, so what is this load? This is the load that has to be lifted or moved. Okay, so that is on the output side. Now what do we do to lift this piece of load? Okay, can we simply stand in front of the load without moving our hands and legs, no body movement, and we just expect this load to rise up? No, it can't happen that way. So we have to do something from our end. Okay, please have a look back again. Effort is what you will provide on the input side. Unless you provide something on the input side, you will never get an output from the machine that we are using. Okay, so let us have a look over here. Suppose, now this is just an example, a hypothetical case. We have an effort of 50 newtons. Okay, so this is the input that you are giving to lift the particular load. Okay, so this is the input and this is the output that you will get. Okay, so obviously if you apply a little bit of logic to this particular scenario, you will understand that this particular scenario is the scenario of a machine which is making our work easier. Now whatever the machine that is to be used in such a situation, we are not going to discuss the type of a machine being used here just now, but we are going to discuss this particular case in terms of the values. Now you see, you are only applying 50 newtons of force to overcome a load of 100 newtons. So don't you think that this is half of the amount that you have to apply in terms of the load? Okay, the load was 100 newtons and you are only applying 50 newtons of effort. So you are in fact applying half the effort. Okay, so now again let's come to a different scenario where the effort, suppose that you have to apply, is also 100 newtons. So an effort of 100 newton lifting 100 newtons, and then an effort of 50 newtons lifting 100 newtons. Which one do you think is easier? Obviously the smaller effort. Nobody likes to work more. Nobody likes to put more effort. Okay, so you see, although that's on the lighter side of it, you see, effort, you would always prefer your effort that you have to apply to be lesser than the load. Okay, so that fact, in fact, is what is making our work easier. Okay, so lesser effort, more output. Okay, so this is basically in terms of what we call as ease of doing work. Okay, so this is one example over here. Similarly over here, now let's come to the second scenario, increasing the speed of doing work. Okay, now suppose you have to cut a piece of cloth. You all must have visited a cloth shop where the cloth owner or the seller, they usually have a particular kind of a knife. Now I've tried to draw the diagram of that knife over here. These are the operating handles, okay, and these are the long cutting arms. Okay, general idea of that. Now it would really not be necessary for us to cut using this particular knife. If there is a small cut made at the end, we can use our hands also to tear off the particular piece of cloth. But do you think that would suit our requirement? Do you think that by cutting the cloth with our own bare hands, it would give us the required output? No. The cut may be all haphazard. The cut, we may have to apply a little more effort over there in tearing up the cloth. So we do not want that. So we want, what do we want? We want a machine that cuts easily and faster. Okay, so you see over here, the piece of cloth will be inserted between the cutting blades, and by a small movement, okay, now by small movement what I mean is, during the process of cutting, you will move, you will put your fingers in these handles and you will compress the handle. So the movement on the input side, this is by the way the input side, because this is where you are doing something, you are inputting your effort. Okay, so the distance moved on the effort side is only this much, whereas if you actually visualize the piece of cloth that will be cut, it will be cut right from here up to here. Okay, so this much cut, this much of a cut, or this much of the output movement, and corresponding movement on the input is only this much. Okay, so don't you think by a small movement on the input side you have actually gone ahead and cut quite a length of cloth. Okay, so it is exactly this process that will enable the cloth cutter to cut a long piece of cloth faster. Okay, so this is a machine that is actually not making our work easier, but it is making our work speedier or quickly. Okay, it is getting the work done quickly. Okay, so such is an example. A pair of scissors here is an example of a machine which is actually increasing the speed with which we do the work. Okay, so it is not always making the work easier. It also involves, machines also involve making the work faster, speedier. Okay, so similarly, now coming to the favorable point or direction of application of effort, let's consider the direction aspect of it. Now here is a very beautiful example that will help you understand this aspect of it. Now suppose this is a well. Okay, now let's have a look at this diagram first. This is a well. Okay, now this is a person who has a rope and a bucket attached to the rope, and he wants to pull out a bucket of water from the well. Now this is a scenario where he puts the rope along with the bucket inside the well and fills it up, and now he is pulling it up. Okay, now he is pulling it up in this particular scenario without the use of a pulley. Now just imagine if you have ever been to a well and tried to do such a thing, you will find that this process will involve a big amount of effort on your side. This is the input side. You will have to do some input work, or you will have to provide some input effort on this side. Okay, and the effort, when you try to pull this bucket full of water like this, in this situation with this rope dangling at the edge of the well, you will find that there will be a lot of friction involved. There will be a lot of effort that you will have to apply in pulling it up. Okay, you may also have to look down into the well to pull it up like this. Okay, so obviously, is this the correct or the appropriate point of application of effort? No, probably not. This will be proved by the fact that once we put a pulley like this over here, hanging over the well, and we have the rope going over the pulley, and at the other end of the rope we have the bucket attached. Now when you apply the effort in this particular direction, you can see that the direction of effort application, now earlier the effort application was in the upward direction because you were pulling it up. Okay, you were pulling it up, so the direction of effort was upwards, whereas here the direction of effort is more or less downwards at a slant angle. Okay, so over here you can visualize that you can even use your body weight. You can dig your one of your legs on the ground, and then you can pull up the bucket full of water with a lot more convenience, okay, in comparison to the case over here. Okay, so by the use of this particular pulley, which by the way is a machine here, the direction of application of effort has also been changed. Okay, so this change of application of this change of direction of the application of effort is what is making our work of pulling up the bucket full of water easy. Okay, so this is a case which belongs to the favorable direction of application of effort. Okay, so these are some general ideas of a number of things that machines do. Okay, so now having studied this, you should be able to think more broadly in terms of what machines are able to do in our lives. Okay, it is not just about reducing our effort. It is also about speeding up the work. It is also about thinking smartly, acting smartly, where to apply the effort to reduce the amount of input work. Okay, so all these things will give you a better understanding and a better background to move ahead. Now, coming to the principle of a machine. Now, a machine will have its own operating principle, and it is based on the simple concept that you provide an input, you get an output. Okay, as long as you don't provide an input, you will never get an output. Okay, nothing moves on its own. Okay, so this is the principle, general principle of working of a machine. And then again, obviously very important from the point of view of this chapter, practically your output will always be less than input. Whereas ideally, in case of ideal machines, there will be a number of cases that we will have to deal with numerically also, where we will discuss ideal machines. Ideal machines are perfect machines. Basically, these are hypothetical machines. They cannot be prepared, they cannot be made, they are practically impossible to make in real life. Okay, so output is equal to input. Whatever input you provide, you get the same amount of output, which is practically not possible. Okay, because there is always some energy loss involved in the operation of all machines. Okay, I can give you a practical example, a very basic example of the motor which we all, AC motors which we all use in our homes to pull up the water from the ground floor to maybe the second floor or the third floor. You put the plug in, you switch it on. Okay, so you are providing electrical energy, electrical energy in terms of input to that machine, and there is some work being done. But do you think that the motor will not heat up in the process? Yes, obviously after running for, let's say, 15-20 minutes, the motor gets heated up. Okay, so there will be heat loss, there will be friction loss. There are other types of machines also, not just the motor. You go to mechanical engineering field, you find lathe machines, you find different types of machines, you find the paper printing machines. Okay, so all these machines have different body parts, some rigid, some non-rigid, some will involve friction losses. A lot of them will involve friction losses. So such losses are the reasons why the input that we provide, we do not get the same amount of output on the other side, because some part of the energy that we are supplying is used up in the operation of that machine. Okay, so practically, for all practical cases, please remember your output will always be less than input. Okay. Okay, now moving ahead, we have some technical terms to study. Okay, now obviously load and effort represented with capital L and capital E, I have already explained to you. Load is something that you have to lift or move. It is actually the resistive force that you have to overcome. Okay, effort is what you provide, the force that you provide on the input side. Okay, now coming to the third technical term or the parameter, you have MA, capital MA, which stands for mechanical advantage. Now mechanical word obviously is with reference to machine. What is this advantage that we are talking about? So let us understand this in detail now. Mechanical advantage has a formula, load upon effort. Now load is also a force, effort is also a force. So the division of two similar things will give you, in the result, you will not have any unit. Okay, so mechanical advantage will it can have a number of values, but it will never have a unit because it is the ratio of similar quantities. Okay, now here is an example which will help you in understanding what a mechanical advantage means. Okay, and for a machine, what does mechanical advantage value convey? What information is carried by this particular term, mechanical advantage? Okay, so let's take an example. Now load, there is a load of 50 Newton that has to be moved, and you are having to provide an effort also of 50 newtons. Okay, so 50 newtons you are giving as an input, and you are getting an output of 50 newtons, or there is a load of 50 newton that will be lifted up or moved by the application of 50 newton itself. So if you put it in the formula, 50 by 50 will give you a mechanical advantage value of 1. Okay, now value wise this is fine, but just try to visualize a situation in which you are having to put an effort of 50 Newton to lift a load of 50 Newtons. Is this really making your work easy? No. In fact, you are having to put the same amount of effort as the load. Okay, so no real ease of working. Okay, this is probably a machine which will not give you the feeling that you are providing lesser effort to do the work. Okay, now here is an alternative example. For lifting a load of 50 Newton, this is a different type of a machine. So for lifting the same load by this machine, now the effort that you have to provide is half of that, which is 25 Newtons. Okay, so visualizing this situation again, you will agree now that in this particular machine, your effort is halved. Okay, so you would prefer such a kind of a machine, because here your effort has to be less. Okay, so in fact your effort is halved over here. Do you really want that to make your work easy? The answer is yes. Okay, so now in this particular case, if we put the values in mechanical advantage formula, you will get 50 upon 25, which will give you a mechanical advantage value of 2, which is greater than 1. Okay, so for all machines having mechanical advantage value greater than 1, you will see that your effort will be reduced. Okay, now obviously reducing or the reduction of effort means that your work is easy, your work is being made easy. Okay, so higher the value of mechanical advantage, greater it is than 1, the more higher and higher it goes above 1, your amount of effort that you are having to apply keeps on reducing. Okay, so that means greater the value of MA, lesser is your effort. Okay, more easy it will be to do the work. Okay, so would you prefer a mechanical advantage value greater for a machine? Yes, but then it depends on the situation or the circumstance. If you really want your work to be made easy by a machine, if you really want your effort to be reduced, it is then that you will look for a machine with a greater value of mechanical advantage. Okay, coming to the second part, or the third parameter over here, we have capital V, capital R, which stands for velocity ratio. Okay, now as the name itself suggests, it is a ratio of the velocities. Now which velocities? Is something moving over here? So basically by the term velocity, what we intend to mean over here is that whenever we have a particular machine working, you do move some handles, or you do provide some movement on the input side or some side where you have to do something, and there are some body parts of the machine which keep on moving. Okay, so there is a lot of movement involved in most of the machines. So you have over here the velocity on the effort side upon velocity on the load side. So formula wise, velocity ratio has a formula VE upon VL. E obviously is effort, L is load. Now when you talk in terms of the velocity formula, you say that velocity is the in terms of the formula, velocity can be written as displacement upon time. Okay, so suppose in t time, the distance on the effort side is dE and the movement on the load side is dL. Okay, so you can write VE as dE upon t, and you can write VL as dL upon t. So these t's are same, so they get cancelled out. So eventually what you get is dE upon dL. Okay, which is the distance moved on the effort side upon the distance moved on the load side. Please remember throughout, effort is provided on the input side, load is what you have on the output side. Okay, so the movement on the output side and the movement on the input side. So velocity ratio is a ratio of the distance moved on the effort side to the distance moved on the load side. Okay, now formula wise this was there. Now let us understand, taking a particular example of a machine. Now here we have, suppose the distance that is moved on the effort side or the input side, the distance or the displacement in fact that you are doing on the input side is only 2 centimeters. Okay, so you have on your input side, you have enabled a movement of 2 centimeters. So this movement on the input side is resulting in the 10 centimeter movement on the load side or the output side. Okay, so again before we go ahead in terms of the formula, what is this suggesting? If you visualize this particular example of the machine or this particular case, you will visualize that you are only moving 2 centimeter on the input side. You are making a movement of only 2 centimeter, whereas the load side there is a 5 times more movement on the output side. So don't you think this is actually speeding up the work? Speeding up the work. So if you remember the second case that we had discussed under machines, machines can increase the speed with which we work. Okay, so now when we put the velocity ratio formula, when we put the values, dE upon dl was the formula, so we put the values, it comes out to be 1 by 5. Velocity ratio value is 1 by 5, which is less than 1. Okay, so all velocity ratio values which are less than 1 will provide you with a gain in speed. They will make your work speedier. They will enable you to do the work or finish the work at a faster rate or quickly. Okay, so hence for better speed you need a velocity ratio value which is low or lesser than 1. The more less it is than 1, the better speed you will get. Okay, so please remember these are the two very important parameters as far as the analysis of machines is involved, or the nature of the working of the machine is involved. Okay, looking at a mechanical advantage value, you can judge whether that particular machine is making your work easier or not. Okay, looking at the velocity ratio value, you can judge whether that machine is speeding up your work or not. Okay, so that is as far as these two parameters is concerned. Now coming to the last parameter that we have efficiency. Okay, it is represented with the symbol eta. Okay, it looks like an N, but it has an elongated end over here. So you have efficiency, the general formula in the second chapter also you have studied. Efficiency is work output upon work input. Okay, so whatever output you get on the application of some input, that ratio gives you the efficiency value of a machine. So obviously greater the value of efficiency, better is the machine, because lesser will be the loss. Okay, and generally efficiency is represented in terms of percentage. So whenever you have to represent efficiency in terms of percentage, the only thing that you have to do is you have to put a multiply sign into 100 over here. Okay, so you will get the efficiency value in terms of percentage. Now talking more specifically in terms of machine, now this was a very general formula of efficiency for a machine. Now we will try to establish a relationship between this efficiency and these factors that we have studied, L, E, MA, VR. Okay, so all these parameters we have to relate them to the efficiency of the machine. Why? Because MA and VR are also the parameters, very important parameters related to machines. Okay, efficiency also eventually is something related to machines. So let us have a look. Now work output. Work has a general formula of force into displacement. Okay, since it is on the output side, so I will write force on the output side multiplied by displacement on the output side. Similarly, in the denominator you will have work on the input side is equal to F into displacement. Now all these F and this F and this D is obviously on the input side because this is work input. Okay, so now again visualize, force on the output side is nothing but the load, whereas force on the input side, the force that you were providing, remember when I had explained the effort that you apply on the input side, that is E. Okay, similarly now multiplied by D on the output side, displacement on the output side is nothing but your DL. Okay, so I put DL over here. Similarly displacement on the input side is DE. Okay, so this formula now comes down to this. Okay, and we have already studied L upon E. L upon E is nothing but mechanical advantage. So I have put L upon E in this bracket, then multiplied by, now if I bring this DL down over here, it will come in the denominator of the denominator. So you will have 1 upon DE upon DL. Now the reason why I have written it in this fashion is because you can see over here DE upon DL is nothing but your velocity ratio. Okay, so in the last line now I can write efficiency is equal to L upon E is MA, okay, L upon E is MA, and in the denominator you have dE upon dL, which is nothing but your velocity ratio, okay. So efficiency has a formula in terms of MA and VR. Efficiency can be written as MA upon VR, and again, if you want to represent it in terms of percentage, you will just put multiply into 100. Into 100 you will write over here, okay. Okay, now one last thing that we have to, I would like to tell you all before I finish up with this particular introductory video on machines are these terms: force multiplier and speed multiplier. Now these are some of the terms that we use for particular types of machines, okay, which we have already discussed, by the way. The only thing that I wanted to give you was these particular terms. Now, when will we use a term force multiplier for a machine? You see, take this example that we had already discussed. You provided an effort of 25 newtons. Your effort was doubled, okay. Your effort was multiplied 2 times to overcome a load of 50 newtons, okay. So can you call this particular scenario or this particular case of machine as a force multiplier? Yes. MA value is 2, okay. So this machine is acting like a force multiplier because the force that you applied has been multiplied 2 times, okay. So this is a case of a force multiplier. Force multipliers always make your work easy. They always reduce your effort, okay. Similarly, in case of speed multipliers, speed gets multiplied, okay. It makes your work faster, okay. So all those machines which make you do the work faster will be called as speed multipliers, okay. So for all speed multipliers, all machines which will enable you to do the work faster can be called as speed multipliers. Please remember that a machine at one given time, at one given situation, it can either act as a force multiplier or as a speed multiplier, not both of them at the same time, okay. So I hope that you've got a fair bit of an idea, a base building exercise this was, okay. So you have got to know some of the important aspects, some of the important terminology related to the machines. Now these load, effort, mechanical advantage, velocity ratio, efficiency, all these things are very important with regards to what we will be doing in the future lectures of this chapter, okay. Now this was machine description in general. There are lots and lots of different kinds of machines. The 2 main types that we have to study as far as our syllabus is concerned is, one is levers, the other is pulleys, okay. So lever and pulleys is what we are going to do in the future videos in detail, okay. First I'll start with levers and then we'll go on to pulleys, okay. So please revise till what we have done, okay. It is only then that you will be able to understand the future videos better. Thank you.